Click the link in the description to download your own copy of this video's problem. Hey guys, welcome back to another fantastic chemistry video, and today we're going to talk about drawing mechanisms of a reaction. Very simple, very easy to do if you practice it enough. Let's get into it. So here we have a reaction where we have a tertiary iodide becoming a tertiary ether in the presence of methanol and heat. All right, so this is an SN1 reaction. Now, how do I know that? First of all, the solvent, polar protic. It's a good giveaway. There's nothing else, no other reactants in this reaction except for the alkyl halide. There's just methanol, heat, and the alkyl halide. It's a good indication it's SN1. It's also a tertiary halide, which also tells me it's probably SN1. Everything's setting up for an SN1 reaction or an E1 reaction, but this is SN1. They only want us to consider the SN1 product. The E1 product is not drawn, so we're not going to worry about it. Step 1, the leaving group leaves. Takes the bond electrons with it, forming a carbocation. Let me just draw it out so everyone can see it. Cation right there, and the iodide is here somewhere as well. Now, at this point, we have methanol in this reaction. Methanol is this structure. Now, the lone pair of methanol now will attack the carbocation, and that will give us the carbon-oxygen bond. And now we're drawing in the protonated ether. Now at this point, you could use iodide to take off the hydrogen off of the oxygen to essentially deprotonate the ether, or you could use a solvent. Either one. The books often use the iodide. I'll just use the solvent this time just to be fun. There's a lot of methanol in these reactions. The solvent, it is the solvent after all, so there's a lot of it. Oops. Let me use the same color arrow. So the lone pair now deprotonates the hydrogen, giving you the product. And that's how you do this reaction. This is a typical traditional SN1 reaction. Okay? Now, I hope you found this video helpful. If you did, go ahead and slap that like button for me. That really does help me out. It tells YouTube's algorithm that my video is useful to people learning organic chemistry and helps me out as a YouTube content creator. If you could, please, if you haven't already done so, hit that subscribe button. Stay on top of new videos I'm going to be releasing all the time to help you learn organic chemistry. And if you could, please share my content with your friends and family. If they're struggling with organic chemistry, let them know I'm around. Maybe they could use my help. And as always, guys, I want to say thank you for watching, and good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.